Hope it records the right screen. All right, so let's go over some converting equations. So the first one was number 9. All right, so here was the question. So it said convert the following equations from rectangular form to polar form. So number 9, we have a circle with it's shifted up or down 10, and it has a radius of 10. So it's going to be tangent to the x-axis. So there's like a shortcut way to do that, and I'll show you at the end, but we'll go through it first, like without the shortcut. All right. So we got for number 9, we got x squared plus y plus 10 squared is equal to 100. Now, when we're converting from polar to rectangular or rectangular to polar, all right, in my mind, I'm always going to refer to like these. And this is like how we can convert from one to the other because they're equal. All right, and this is on page 5 of the notes. So x is our cosine, y is our sine, r squared is x squared plus y squared, and tangent of theta is y over x. So sometimes we have x and y, and we could just straight up plug in these. Other times we might just have r, and maybe you have to square both sides in order to get r squared. Or maybe you're given an angle, like theta equals an angle, and then you have to use this, and we'll do an example like that too. But since I have an equation where we just have x and y, all right, I'm just going to substitute r cosine theta for x and r sine theta for y. All right, so we get r cosine theta, all that's being squared, plus r sine theta plus 10, all that's being squared, equals 100. All right, now to get it into polar form, we want like r equals something. We want r isolated. So I'm going to FOIL all this out. So we get r squared times cosine squared plus, and then we're going to FOIL this out too. So r squared sine squared of theta plus 10 r sine theta plus 100 equals 100. All right, so that's just foiling everything out. All right, now we're gonna look for, so I noticed we have like sine squared and cosine squared, so keep identities in mind. Like we know that could equal 1. All right, and we can also, get rid of this 100 by subtracting that on both sides. So I'm gonna do that. All right, so now I have 0 on this side. And now for this part, all right, I noticed just a common factor of r squared with these two terms. So if you factor that out just with those two terms, you get r squared times cosine squared plus sine squared. All right, and that's going to equal 1, so that's nice. So you get r squared times cosine squared plus sine squared plus 10r sine. Oh, 20r sine. When I FOILed it, I forgot to double that. So that should be a 20, and that should be a 20. That's my fault. All right, so now this equals 1. So now we have r squared plus 20r sine of theta equals 0. So now it's a lot more simplified than this. All right, and we have two terms with r as a factor. So we could factor out an r, and we get r times r plus 20 sine of theta equals 0. So just like when in algebra 2, when you learned how to solve quadratics by factoring, once it was set equal to 0 and it was factored, you could set each factor equal to 0, and that would be a solution to the equation just above this line. All right, now r equals 0, that on the polar grid would just be like the origin, right? So like r equals 0 means you're moving 0 units away from the pole. So, that's kind of irrelevant. So we could cross that out. And then we get r equals negative 20 sine of theta. All right, and that would be our equation for this circle that's tangent to the x-axis. To the x-axis. All right, so if we were to sketch this, we would move down 10 from the origin. So you got 0, negative 10. And the radius is 10. So in general, a circle that's tangent to the x-axis is going to be r equals the diameter times sine. And if it's tangent to the y-axis, it'll be r equals the diameter times cosine. And this number here is going to be the diameter of the circle, which I said, but what I meant to say was the negative implies it's going to be below or to the left of the x or y axis, and if it's positive, it'll be above or to the right of it. And if you look at the notes from that section, we generalize that somewhere, like right here on page 7. So how can we quickly write the polar equation of a circle tangent to the x or y axis? All right, you can use one of these. All right, so if you want to jump to the last step, you could do that. But, this just shows how you get there. All right, so that's number 9. See, someone sent me a question. So yeah, how does cosine squared plus sine squared equals 1? All right, that was one of the identities that's a Pythagorean identity. Sine squared plus cosine squared is equal to 1. And the reason why that's true is because if you think of the definition of sine is y over r, and cosine is x over r. All right, so to prove that this is true, this is called the Pythagorean identity because of the Pythagorean theorem. All right, if you now take this and square everything, you get x squared over r squared plus y squared over r squared is equal to 1. And then multiply everything by r squared. And we get x squared plus y squared equals r squared, which if we actually use the definition of x, y, and r, remember x, y, and r come from an angle in standard position. So it has to be at the origin with one side on the positive x-axis. X and y is a point on that terminal side, and r is the distance that that point is from the origin. So this would be the x coordinate, that would be the y coordinate, no matter how you rotated it, as long as it was in standard position. And it's called the Pythagorean identity because if you now do the Pythagorean theorem, a squared plus b squared equals c squared, you get x squared plus y squared equals r squared. All right, so this is why, but I'm not a big memorized guy, but this is something that you should just memorize and use. You're going to use it a lot in calc, and we used it a lot in trig, especially when we did identities. All right, and then there's variations of that too, and that's how we were able to put conic sections like ellipses and circles into polar form or parametric form. All right, and then we use secant squared minus tangent squared equals 1 to put hyperbola into parametric form. All right, so you definitely want to know that. Okay. All right, so that's number 9. All right, now let's try number 21. Thick piece of paper. All right, 21. I'm going to recycle my paper here. All right, so 21, we have, so it says convert the following equations from polar to rectangular. All right, so this right here is theta equals pi over 2. All right, theta equals pi over 2. So we got to convert that. Oh, that's why it doesn't make sense. Now, before I show you like the straightforward, like kind of long way of doing it, you could also kind of just sketch a picture. And so if theta is equal to pi over 2, remember that like r could be anything. So if r is positive, then like this would be where theta is pi over 2 on the polar grid, where r is positive. And if r is negative, then we go behind. And r could be anything because it's not included in the equation. Just like if you had the rectangular equation x equals 0, right? Like y could be anything as long as x is 0, and that gives you the equation of the y-axis. So if you have like theta equals just an angle, all right, so if I were to jump, I know no one said to go over 22, and I didn't think it was a sine, but in 22, theta is equal to pi over 4, all right? So this is pi over 4 where r is positive, and this is pi over 4 where r is negative. All right, now this line in rectangular form would just be y over x, where the slope is 1 and the y-intercept is 0. So like sometimes when you just have, not sometimes, when you have just theta equals an angle, you could kind of just graph it and see what the, it would have a y-intercept is 0 and just kind of use the angle to see what the slope would be, all right? So it's like kind of like a quick way to kind of check your work. So now, how would you do one like this where you're given just theta equals an angle in radians and nothing in terms of r? So that's when you want to use tangent equals y over x. All right, so when you're stuck on converting something from polar to rectangular or rectangular to polar, you want to refer to these right here. So we can use this to incorporate x and y because that's what it means to put something in rectangular form. Like don't write it in terms of r and theta, write it in terms of x and y. All right, so if I use this, if I know tan of theta is equal to y over x, then this implies that the tangent of pi over 2 is equal to y over x. And then the tangent of pi over 2 is something you could evaluate, all right? That's just equal to undefined. So that doesn't help. So yeah, the slope of that line would be undefined, but it still has the equation of that line, all right? But we gotta be resilient. We can't just give up just because it says undefined. So what you could do, and this isn't really in the notes, but you could switch to cosine, not cosine, cotangent. All right, so first, why are we abandoning this? Because this is undefined, equals y over x. So kind of hit a dead end there. But if we use the cotangent, the reciprocal is equal to x over y, which isn't in the notes, but it's just one extra step, then we could do the cotangent of pi over 2 is equal to x over y. And that's going to be 0. The cotangent of pi over 2 is 0 by, if you use like a unit circle, you'll see it's 0 over 1. All right, so now if we cross multiply, because 0 is just 0 over 1, we get 1 times x is x, 0 times y is 0, and there's our equation of the line, x equals 0, which again makes sense if you graph it, because this is, the polar grid is, you can overlap it onto the rectangular grid. It's not two separate things. It's like, but it's just two different representations of the same thing. So there you go, x equals 0, all right? So the next one was number 23. Nobody likes you when you're 23. All right. 23, we got r equals 5 times the sine of 2 theta, right? So this is also a tricky one because we got 2 theta in there. But I'll show you what you can do. 5 sine of 2 theta. Now, does anyone recall like this, the sine of 2 theta sound familiar as to something that we did back in the day? Okay. Nice, double angle formula. All right, so again, this is a tricky one. This isn't just like, this isn't trivial in any way. But yes, double angle formula. The sine of 2a will equal 2 times the sine of a times the cosine of a. All right, so this is why all those identities come into play. It ends up helps you take something that's kind of hard to work with and then make it easier to work with. So So now this would become r equals 5 times 2 times the sine of theta times the cosine of theta, which is 10 sine of theta cosine of theta equals r. All right. Now, what do we do from here? Well, we have r and we have sine theta cosine theta. So if we look, we know that r squared is equal to x squared plus y squared, which implies that r is equal to the square root of x squared plus y squared. And we also know x is equal to r times cosine, which means the cosine of theta is equal to x over r. And if we know y is equal to r sine, we can then sub in y over r in for sine. So in order to help us go from an equation that has sine theta cosine theta r, which is in polar form, to rectangular form, we want to use these to substitute and get everything in terms of x and y. So r we can replace with the square root of x squared plus y squared equals 10 times the sine of theta, which is y over r, times the cosine of theta, which is x over r. So now we sort of have it in rectangular form, but we still have this r here. So you could sub in square root of x squared plus y squared in for that as well. All right, now everything, if we kind of like ignore this part, everything is in terms of x and y. So technically now it's in rectangular form, but we can write this a little nicer we could take this and write it as a rational exponent. So this would be x squared plus y squared to the 1/2 power equals 10 times y times x all over x squared plus y squared. Because when you multiply these three together, you multiply across. You multiply the numerators together, 10xy or 10yx, and then radical x squared y squared times radical x squared y squared is just x squared y squared. All right, then you could cross multiply because this is x squared plus y squared to the first power. And these both have the same base. So when you cross multiply, you could just add the exponents. So x squared y squared to the 1/2 power times x squared y squared to the first power is going to be x squared y squared to the 3/2 power, because that's what it means to, you add the exponents when you multiply two things with the same base. And 1 plus 1/2 is 3/2. So that equals 10yx. And I mean, you can't really simplify that more. So that's the best you could do. And so there you go. All right, number 15 is the next one. Absolutely. So 15 says, all right, we can get rid of that. Things in all different places. All right, so number 15 is, oh wait, I need that one still because that has all the questions I gotta go over. So 15 is r equals -2 times 7 times the sine of theta plus 4 times the cosine of theta. All right, so first thing I'm gonna do is the same thing I do anytime I have like an equation where I have a fraction, and it's gonna be to get rid of the denominator. And since it's just one fraction equal to r, I could cross multiply. So we get -2 is equal to r times 7 sine of theta plus 4 cosine of theta. And then we distribute. So I'm going to write this as 7r sine theta plus 4r cosine theta. So I'd like to keep my r's and cosines and r's and sines right next to each other, because you can really multiply in any order, but I strategically put it 7r and not r7 because I know that r cosine converts to x. and r sine converts to y. And that's the first thing I thought of when I saw this original equation. I'm like, all right, if I could just cross multiply and get these r's next to the sines and the cosines, then I can easily substitute in x and y in there. All right, and that's what I'm going to do now. I'm going to take r sine theta and r cosine theta and replace them with y and x respectively. So I get -2 is equal to 7y plus 4 times r cosine, which is x. And, that's a standard form of a line right there. So, so you can leave it like that. You don't have to do anything else. Now, if you wanted to graph that, you can obviously isolate y and put it in slope intercept form, or you could leave it like that and find the x and y intercepts and graph it that way. All right. So there's 15. Let me know if you have questions. So the next one is 27. All right, so write the polar equation for the line passing through the rectangular points. All right, so here's the question right here, number 27. All right, write a polar equation for a line passing through these 2 points. So these are rectangular points, x and y. We want to get it in terms of r and sine. All right. So write polar equation for line through -5, 2, and 6, -14. All right, so the first thing I'm going to do is just get the equation of this line first and not worry about converting it to polar. Because if I have that, then that's one extra step closer to, then actually, like, I don't even have any equation right now. So the least I could do is write this equation in rectangular form. So I'll find the slope. So slope is change in y over change in x. So 2 minus -14 is 16. Over -5 minus 6 is -11. All right, there's my slope. And I'm just going to use point slope form because I have a point and I have a slope, and I don't need to use slope intercept form because I don't know the y-intercept. So I'm going to just use any point. We'll use this point. So y minus 2 is equal to 16 over -11 times x minus -5, which is like x plus 5. And at this point, I could just substitute in, r cosine in for x and r sine in for y. But I'm just going to clean this up first and get rid of some fractions. So I'm going to, before I substitute, just get rid of this fraction here by multiplying everything by -11. So I get -11y plus 22 is equal to 16 times x plus 5. All right, then I could distribute that. 16x plus 80 is equal to -11y plus 22. And since I have this 22 on one side and this on the other side, I'm just going to get everything over on one side. So I'll add 11y to the right side so that everything's positive, and I'll subtract 80 on both sides, so I get a -58. All right, so now I have my rectangular equation in a nice standard form where there's no fractions and there's no random numbers being added to both sides. It's like nice and simple. So at this point, I can now use, this is my holy grail for converting equations. I'm going to refer to this when I need to convert and plug in things that are equal. So for x, I'll plug in r cosine, and for y, I'll plug in r sine. So now I have, I'm going to move the -58 on the other side. So I have 16 times x, which is equal to r cosine of theta, plus 11 times y, which is equal to r sine of theta. Okay. And any polar equation, like if you think about how you would type that into the calculator, it's always r equals something in terms of theta. So now we want to isolate r. So we could do that. So this is using our algebra skills and factoring. If we want to isolate r, since it appears in both of these terms, we can just factor it out. So r times 16 cosine theta plus 11 sine theta is equal to negative 58. And then get r alone by dividing everything by 16 cosine theta plus 11 sine theta. And there it is. All right, so it's not really considered done in polar form unless you have r by itself, like r isolated. All right, so that's 27. So no one likes you when you're 23. 15, so your King Sierra. 27, that's when MLB players reach their power peak. And 31, well, that's the best age you can be. So here we go, 31. All right, 31 says convert each polar equation to a rectangular equation, then determine the graph's slope and y-intercept. Hint, think, sum and difference formulas. There's a hint. All right, so let's use the hint. All right, so we got r sine of theta minus pi over 4 equals 2. All right, and the question is convert to rectangular. So we have the sign of a difference, so we can use the difference formula for sine. And I realize that that's not something that you have tattooed on your arm or committed to memory, but if this was a normal year where we gave tests and there weren't open notes, I would give you that formula if you needed to use it. But now just if it comes up on like something, just Google it and it'll pop right up. So the difference formula for sine, I'm pretty sure, because I don't make you memorize things, so why the hell should I memorize things? I'm pretty sure it's sine of A cosine of B minus cosine A sine B. Let me check. Oh, I have it written down right here. I should have just pretended like stupid me. 31. Yeah, sine, cosine, minus. Nice. Good job. All right. So now this will become r times, we'll put this all in parentheses, all right, times the sine of theta times the cosine of positive pi over 4 minus the cosine of theta times the sine of pi over 4 equals 2. And what that allows is it gets rid of this like expression inside the sine, and you're allowed to now evaluate this. So cosine of pi over 4 is root 2 over 2. And so is the sine of pi over 4, root 2 over 2. So this becomes r parentheses root 2 over 2 sine theta minus, I just like to write the coefficient in front of the function, root 2 over 2 cosine theta equals 2. And then, fractions really get on my nerves, so I get rid of them by multiplying by denominators. So if we multiply both sides by 2 and distribute, and we can distribute the r as well. All right, then we get, this will cancel and that'll cancel. So we get root 2 r sine theta minus root 2 r cosine theta equals 4. And so whenever you have like an r chilling outside parentheses with some trig functions in there, you definitely want to distribute it, because again, back to this, when we have r with cosine, we could sub in x. And when we have r with sine, we could sub in y. And if you're trying to convert to rectangular, that's what we're doing here. That's what we're trying to do, to get our cosine and our sine together so we can just plug in x and y. All right, so r sine is equal to y. So we get root 2y minus root 2x is equal to 4. And, that is the equation of the line. Now, it says, though, not just to write the equation of the line, to determine, I just wrote convert to rectangular, but it also said determine the graph's slope and y-intercept. So you could now, if you wanted to, like plug in 2 points and do it that way. Like find the x and y coordinates and find the slope. Like plug in 0 for x and we can find the y-intercept, and then 0 for y and find the x-intercept. And then with those 2 points, find the slope. All right, or we could just isolate y and put it into point slope form. So divide everything by √2. And we get y is equal to √2 over 2, which is 1x, plus √2 over 4, which we can rationalize. And that becomes 4 √2 over 2. So it's 2 √2. And so now it's in point slope form. So mx plus b. So our slope is 1. And our y-intercept is 2 times √2. Okay? All right, 25. 934. All right, maybe we can squeeze these 2 in, and then I'll tell you what the plan will be for tomorrow. We'll see if we can get these in first. Maybe we just do one. We'll see what time it is. All right, so 25 was... So find the rectangular coordinates for each pair of points, then find the distance in simplified radical form between those 2 points. All right, so we got to convert and find the distance. So convert to xy and find the distance. All right, so we got the point 2 comma 2 √3, or 2 pi over 3, and 4 comma pi over 6. All right, so actually I will go over this. I think we'll have time, but I don't want to like have everyone run out the door while I tell you the plan for next class. So let me tell you that, and let me pause this for a moment. All right, number 25. For this question, we have to find the rectangular coordinates for these 2 points, and then find the distance between those points. All right, so we got to convert these first. Now, recall that when points are in polar form, all right, this is r and that's theta, all right, and that's r and that's theta. And we've talked about, how to graph those points by, rotating in this angle's direction and then moving r units away from the pole or the origin. Okay, we know that x is equal to r times the cosine of theta, and y is equal to r times the sine of theta. So to convert this point, we can use these definitions here. So this point will be x is equal to 2 times the cosine of 2 theta over 3, or 2 pi over 3. All right, and y is equal to 2 times the sine of 2 pi over 3. Okay, looking back at our tables and our unit circle, all right, we recall that the cosine of 2 pi over 3, all right, that has a reference angle of 60 in quadrant 2. So the cosine of 60 is 1/2. So cosine of 120 or 2 pi over 3 will be -1/2, because in quadrant 2, cosine is negative. All right, only sine is positive in quadrant 2 and cosecant. All right, so this would be 2 times positive √3 over 2, because the cosine is 60, or sorry, the sine of 60 is √3 over 2. All right, this has a 60-degree reference angle, and it's in a positive sine quadrant. So this first point converted to rectangular would be -1 comma √3. All right. And now we do the same thing for this point here. So x is equal to 4 times the cosine of pi over 6, and y is equal to 4 times the sine of pi over 6. So the cosine of pi over 6, that's the cosine of 30, that's √3 over 2. So this is 2 √3. And then the sine of pi over 6 is 1/2. So this is 4 times 1/2. So we get 2. All right, so this point would be at 2 √3, comma 2. All right, now we're going to find the distance. And it said specifically to find the distance in simplified radical form. So we want to keep it in radical form, not convert it to a decimal. So, whoops. So we're going to use the distance formula here. So we get, subtract the x's. So -1 minus 2 root 3 squared plus root 3 minus 2 squared. So now we're going to have to FOIL those out because, that's hard to simplify without doing that. So like you don't want to, what I'm trying to say is you don't want to square like -1 and -2 root 3 because, we have a plus b squared or a minus b squared. That's equal to a squared minus 2ab plus b squared. It's not equal to a squared minus b squared. All right. So this will become, so when you FOIL that out, that'll be 1 plus 4 root 3 plus 12. All right, and when you FOIL this out, that will become 3 minus 4 root 3 plus 4. All right. Okay, and then we could combine like terms. And luckily, these just cancel right out. So it's 1 plus 2, 12 is 13, plus 3 is 16, plus 4 is 20. All right, and the square root of 20 is 2 root 5 because 20 is 4 times 5. So the square root of 4 is 2, and the square root of 5 can't be simplified. So that's just root 5. All right, so that is the distance between these 2 points, 2 root 5. All right, and we did that by converting to rectangular and then using the distance formula. All right, and then the last one that we are going to go over, or that was requested to go over, was number 29. So 29 says that we need to determine the points of intersection of the polar equations. All right, so do not repeat points. So, that means like pi over 2 comma 1, that's the same point as -1 comma 3 pi over 2. All right, and I should have said the radius first, the first time. All right, so what we're going to do is kind of treat this like a system of equations. We have r equals cosine of theta and r equals 1 minus cosine of theta. So when we want to find points of intersection, we're basically solving the system. So we could do that by substitution. All right, we know that r is equal to r, so we could set cosine theta equal to 1 minus cosine theta. All right, so we solve by isolating cosine theta by adding it to both sides. So, cosine theta, so that's 2 cosine theta equals 1, and then divide by 2. All right, and if we don't want to repeat points, so we're just going to find angles between 0 and 360. Because any other point would be coterminal to that. So the two solutions for this, well, it's cosine equals a positive angle. So it's got to be angles in quadrants 1 and 4. All right, cosine is negative in quadrants 2 and 3. So we know that the cosine of 60 is 1/2. So theta could be pi over 3. And then the reference angle, or the angle with a reference angle of 60 in quadrant 4 would be 300, which is 5 pi over 3. Okay, so now, if we want to, so we're trying to find the points of intersection, in polar form. So right now we just have theta. We got to find out what r would be. So if we make a little table here, we see that theta is pi over 3 or 5 pi over 3, which makes r cosine of theta equal to 1/2 because, the cosine of pi over 3 is 1/2. And also the cosine of 5 pi over 3 is 1/2. And we want to make sure these aren't the same points for the other equation. So 1 minus 1/2 would also be 1/2. And same thing here. So if we look at a polar grid, we have 2 points right here. All right, we got this point, so r comma theta and r comma theta. So we have the point 1/2 comma pi over 3 and also 1/2 comma 5 pi over 3. So these aren't repeated points because if you move pi over 3 and then 1/2, all right, let's assume that like 1, 2, 3, 4, we'll say that's like 1. Say that's 1 and then, all right, so every 4 boxes is 1 on the radius. So 1/2 pi over 3 would be rotate pi over 3 and then go out 1/2. That would be right there. So in the positive direction. And then 1/2 comma 5 pi over 3 would be rotate 5 pi over 3 and go out 1/2. So these are different points. So we're going to, express both of them as answers. So both of these points work. And those are all the problems that you asked to go over. So have a great day.